And I think we're live. I guess we'll find out in a second.
I got
Everything's green across the board. Yep, everything looks good. Hey, Don, how you doing?
Good. How are you, Craig?
I'm doing well. These will be coming out, I think, the beginning of May. I sent you a sheet with all the.
Oh yeah, I have to look at that. Yeah.
So, let's. And I'll send you another one when I post these, which will probably be later today. But it's going to be a busy day. Lots going on.
Yeah.
And let's jump right into it. So we now have QNode OS, which is a quantum computing operating system. What sets quantum computing operating systems apart from other ones, John?
Yeah, so this one's specifically designed for quantum networks. So what it does is it abstracts hardware complexities. So what that means essentially is that it allows users to program quantum applications without needing expertise in quantum physics. So think about back in the day, and this is just me thinking about this, but where back in the day you had to program assembly language, and then because that's what the computer talks. Then other solutions and other programming languages came out, and then you didn't have to know assembly. You could use these other programming languages. This is similar to that. So there's a few key features that it includes. So one is there's this hybrid classical quantum execution, which merges classical processing, which is, let's say, network messaging, with quantum operations, which is entanglement generation or gate execution. So programs will offload tasks to classical systems unless there's quantum specific steps that are required. The next thing is hardware agnostic. So that means it supports multiple different quantum processors, including the which the trapped ion qubits. So this allows it. So the way it works is there's modular drivers that translate the high level code into hardware specific instructions, which is cool. And the last thing is multitasking. So it enables concurrent execution of applications. So you can run compilers and schedulers on a single quantum node. So for example, they demonstrated that delegated quantum computing between client and server nodes while managing entanglement distribution. So this is awesome. This is the next step. I think this is the next step, critical step for the adoption and future of quantum computing. What do you think, Craig? Do you think this has legs, this has merit, or is this vaporware?
Well, it's vaporware for you and me because we're not going to see it. But when you have a standardized operating system that runs on platforms, that's when the software truly starts to get developed. That's when you can develop a set of tools for developers to actually do the development. Up till now, I think they must have just run a hodgepodge of whatever, their own self-built stuff.
I think so. Yeah, it was probably just some like prototype interface that was developed, right? That were specific to each group of people, I guess, right?
Yeah, so basically before something like QNode OS, most quantum computers did not have fully fledged operating systems like classic computers. Instead, they relied on classical control systems with quantum specific software layers. So, they did a whole bunch of hodgepodgey stuff, which includes quantum software development kits like QSIC, Circ, Forest, PyQuil, Penny Lane. And those were things on top of Linux, usually Ubuntu, CentOS, or a similar OS. And then they'd put on these quantum control layers, Open QASM, QCS, and QSIC Pulse. But the point being is it was all over the place. And now if they can load up the one operating system from the get-go, now you can start getting people who can program, do, repair, work on, install, because they can get an understanding of the operating system across the platforms.
Yeah, Yeah, this is so the thing is the true test is going to be, can it work outside of the lab? Because it's not in controlled in experiments, it's in scalability. So can QNode OS manage a, let's say, 100 node network? But early integration suggests that it could, yes. But it seems like, based on everything I read, that this isn't going to be mainstream until 2026, maybe even 2030. What do you think? What did you come to that conclusion too?
I didn't see dates, and always looking forward.
Yeah.
It's always scary, and I rely on you because I don't know, unless I see something in the text, because so I can laugh at you when you do predictions, because I just still want to do them. So
I know you do. Yeah.
Unless I've read something or I know something. I like the concept here. I don't know how far in the future is, but this changes things. Like before, users used to have to write quantum code in Python, for example, use classical host to compile. So a classical computer to compile it into quantum gates, and then a control system sends it to the quantum PU, and then quantum PU returns a result. So now this is all kind of built in.
Yeah.
So it makes it better. Is it, I hope it's not vaporware. From what I read, it's there, and it doesn't sound like it would be super complicated, like putting these pieces together, since the SDKs of the foundation of a lot of this stuff already out there. The question is the cross compatibility pieces. Does all quantum, like, does the abstraction layer, like what happens at the CPU or the QPU layer if this is abstracted at some way? Does the kernel different for each CPU?
Yeah. I don't know. It's got to be. So, or maybe not, because I don't know how QPU architecture looks. But the thing I like is that this solves, if it works, this solves the software fragmentation issue. But there's a lot of challenges still ahead. So it still faces hardware bottlenecks. It still faces decoherence, error rates, and photon loss in the fiber optic channels. So although they've got this one great hurdle, this is great because they needed this. There's still a lot that needs to be resolved in order before this becomes more commercially viable or mainstream for the end user.
Yeah. So the emergence of QNode OS marks a significant leap in making quantum networks practical and accessible, addressing long-standing challenges through innovative design. As quantum technologies mature, systems like QNode OS will play a crucial role in bridging theoretical capabilities with practical applications. So I'm really excited to see this going forward. So maybe this is like DOS 1.0 or some beta version of that. And as we get to see, we'll start to see, a nice Macintosh version or whatever operating system you want to see. I was going to say Windows, but you're not a Windows fan and neither am I. So I think Windows is fine by itself, but there's so much bloatware in it now that I used to run,
especially with that recall feature that is being forced again. So I'm staying far away from that. But I would parallel this more to, and we can have a debate on this, but I would parallel it more to Unix as opposed to DOS 1.0, maybe, just because DOS is like, we do have GUIs now. But anyways.
Sure, I agreed, but I don't know who's watching or listening.
Oh, yes.
If you haven't used Unix before, then So my point being is DOS I love DOS 3.1 was my jam way back in the day.
I liked the original Windows too. Windows was fun. The Windows 3.1,
and I jumped to OS 2.1 when it came out because it was fabulous, and then was 3.1 of Windows NT that really got my attention, and I never looked back from then, but until obviously I jumped to Macintosh.
And didn't IBM have an OS at one time too?
OS 2, and it was
OS
great.
2. Yeah.
So that was my in between Windows and Windows NT was OS 2, because
I remember messing around with that one.
My problem with OS2 was every time you added a piece of software, it took so long to get everything running right because you had to adjust the memory and the parameters and all the environmental variables for that app. But once you got it running, everything was great. You could multitask and do all this stuff back in the days of 486s.
Yeah.
So it was great. Anyway, yes, this is a leap forward, and as networks and operating systems expand, quantum will only be making bigger and bigger strides. We'd love to hear what you think on the thoughts of QNode OS and quantum networking and what the future holds. Leave us your comments. Let me see if that other article is here. A chip has broken a critical barrier that could ultimately begin the singularity. What's happening here, John?
This is cool and super scary. So, Keist, I think it's how it's pronounced. So they've developed a self-learning memristor chip that apparently mimics biological synapses. And the way it does it is it integrates memory and computation. So that enables simultaneous data storage and processing, which eliminates essentially the von Neumann bottleneck, right? So in traditional computing, where the data must shuffle between separate memory and processing units. So the way that they've done this is it uses a 32 by 32 crossbar array of memristors, which each act as an artificial synapse to perform analog AI computations in real time. So the cool things about it is the self-learning error correction. So it's an array that dynamically adjusts resistance based on input signals, and it learns from errors without any external calibration. So for example, during video processing, it would distinguish moving objects from backgrounds with I think it was like 30 dB peak signal to noise ratio, which matches ideal simulations. So on top of that, it's energy efficient, and it has localized AI processing. So the chip enhances privacy and reduces latency by enabling real-time applications like autonomous vehicles and edge devices to run locally with this. So what do you think about this, Craig? Like, do you think this is, what are your thoughts?
Well, I'm trying to get my head around what ultra small neuromorphic chip means. Like, what is ultra small? Do you have how small?
I don't know.
Sorry if I'm obsessed. It was a description, so I'm kind of scrolling through. But I'm excited every time they make leaps forward. I'm always a little afraid when they say, "Oh, this thinks like a human," because most humans don't really have a lot of great logic. So why do we want chips to think like humans?
Why do we want chips to think like humans?
Yeah.
So that
They can be influenced by emotion, by misinformation, by other
so that
things.
they can take over the world.
Well, this is,
And
I guess,
enslave us.
yeah.
Well, there's a lot of use cases. There's,
I
to
guess
be
there
honest,
is be able to learn on the fly and in your environment, not necessarily be programmatically able,
Yeah.
like designed specifically to do this. And we're coming along in that
Yeah.
stuff. But
So
every
by the
time
way, what does it mean by ultra small?
yes,
I think I found that it could be as small as 50 nanometers. The chip.
okay.
Yeah.
So that's not bad. I mean, I guess when we talk about chips, I don't know if I would consider that ultra small, but I'm okay. Well, you know what I mean. Like we're talking about 2 and 3 nanometer
we are. Yeah.
stuff, or that's all I'm saying. That's why I wanted to know if this was some sort of leap forward in size.
No, because I think because of the new architecture, I think this is a new challenge as far as getting it smaller and smaller and smaller. So I think that they feel like 50 nanometers is a achievement based on this innovative architecture. Let's put it that way.
Yeah, and I'm sure it is. Like researchers say, for example, that a chip could separate a moving image from a background during video processing and actually improve its ability to do this task over time. So it improves on what it's doing. I see real world applications like smart security systems, intelligent cameras, security systems that learn normal patterns and alert only to genuine anomalies, privacy enhanced security through on device processing, wearable medical devices that autonomously analyze health data, diagnostic tools that can learn to identify patterns associated with disease, or personalized medicine systems that adapt to the individual patient's responses. What about autonomous navigation, vehicles and drones with enhanced spatial awareness capabilities, navigation systems that adapt to changing environments without cloud connectivity, and real-time object detection and classification for safer transportation? So if we're looking for more on-device processing and recognition of what's happening around them, these things seem to be great. And in consumer electronics, smartphones and devices that can learn user preferences, smart home systems with genuine adaptive intelligence, and voice recognition that continues to improve through daily interactions. These are just some of the things. But I get worried a little bit, because aren't you we moving into a echo chamber that's even worse than what we are?
Yeah, it is. And like, I see this. If this works out, then we have essentially the iRobot, US Robotics, with the emotions and all that sort of stuff. Like we're getting, I think we're getting that close. We're getting that close where potentially we could upload our subconscious to these chips. If I think that's where we're headed. Maybe not.
Yeah, is this the path towards the AI singularity, the integration of MEM resistor technology into neuromorphic computing represents a significant step toward potential AI singularity for several reasons. Structural, similar to human cognition, adaptive learning without explicit programming, energy efficient, comparable to the human brain, and decentralized processing, similar to human neural network. So it's interesting. Though, yeah, I mean, all this stuff scares me at a level, because if you're working with AI at all, it's already lying to you. Like, you tell it to do something, it doesn't do it, and then I'm like, what are you doing? Where'd you get this information? I told you specifically, here's the information. Don't do this stuff. What I was planning an event. The event changes month to month. Here's the details. The location changes. All these things change. But it kept going to cache memory, and then at the end, after I went through it a bunch of times, I said, why did you do this? I'll say, it told me like 5 times, even though you told me not to, I did this, and then blah blah blah. Even though you told me not to, I did this, and then even though you told me not to, I assumed you wanted these things, even though you what? Why are you lying to me? Why are you,
Yeah.
So when you start putting that in a chip at the end of whatever,
we've got to solve that problem. Obviously, that's a huge problem. We're already encountering it. But other uses, that's
what I mean by when you start talking about these things, you think they know what you want. So now you've got these computers around you that's only going to feed you the news you want, the stories you want, the food you want, stuff you want, and now you're in this massive echo chamber of. So I'm just, that's what I see where there's all sorts of reasons that this is scary, but at the same time, having these chips in cars or edge devices really can be groundbreaking for what we can now do.
Yeah. And just to kind of put it into context as to like comparing it with current technology. So NVIDIA's H100 GPU, it consumes 700 watts for AI training. Apparently, this memristor uses less power than a light bulb. That's nuts. So like we're talking less than 65 watts, or however many.
What type of light bulb they're using. Yeah, that looks great. I mean, it'd be nice if they gave us a specific light bulb because they could range a fair bit. But
Yeah.
the concept is it's low energy, fast. It can learn on the fly without specific programming.
Yeah.
And enabling all these new types of features that we never thought of before. I'm really looking forward to it. But, at the same time, there's always, when we look at this stuff, there's always this potential scary output. So what do you think about these memory store technology and the neuromorphic computing chips? Do you think this is the next step in not only AI, but self-driving vehicles, the medical, all the different types of advances we talked about? Or do you think this is just going to be not what it's made out to be and another flash in the pan of something that could have been? Let us know your thoughts. So in Minority Report, they famously introduced pre-crime, where they had the precogs who would determine if you were going to commit a crime beforehand and you'd get arrested. And now it seems like the UK is using AI to do the same thing. They've got a murder prediction algorithm. What's happening here, John?
Yeah. So first off, they're not using human beings or whatever those precogs were, like in Minority Report. This is all computer.
Okay, when I say the same thing, I'm sorry. They were
no.
Yeah,
you didn't. I don't think you
yeah.
said it. I just want to make sure that we're clear. We're starting at everyone understands where we're starting from. So, yeah. So they're dubbing this the Homicide Prediction Project, and the tool uses machine learning algorithms to analyze data sets of 100,000 to 500,000 individuals. I don't know that number, which includes, and this is scary, criminal records, mental health history, addiction, self-harm, and domestic abuse reports. So the data sourced from the Ministry of Justice in the UK, the Home Office, Greater Manchester Police, and the Metropolitan Police, with inputs from suspects, victims, witnesses, and missing persons. So the scary part about this is that the data scope includes sensitive health markers like mental health, disability, vulnerability, and non-conviction records. So suspects that weren't even charged. So this, so now in the UK, if your record gets expunged or whatever, it's never expunged anymore, which is scary. This is dystopian scary crap. The other part of it, and don't even get me started, is on the bias, right? What are your thoughts, Craig?
I'm always worried about this stuff, but when they're looking at utilizing data analytics to forecast criminal activities based on historical records. So people talk about racial profiling. So they're not going to, so all of a sudden they hand it off at AI and they're just going to call it something else.
They're going to blame the AI for any problems.
Yeah. So it's not humans who are biased. It's the computer. So, no one's in trouble for that. So I don't know. It feels a little bit like a scapegoat, but two, isn't the UK in enough trouble right now with, it seems like they're turmoil. They don't know which way they're going from a law point of view, and you're more likely to get arrested for making a meme than to do an actual crime. And now they want to do pre-crime, so they're going to guess that I'm going to post a meme on Facebook ahead of time, and send the cops to my door and say, "You were thinking about posting a meme. You're in trouble."
Yeah, that is one country I will never move to based on what they're doing. This is crazy. It's nuts because there's so much privacy violation. So they're collecting sensitive health data without explicit consent. And that, I think, violates GDPR compliance issues. But, they're the government, so they can probably get around that. And I don't like that. I don't like what they're doing. I don't like this. I don't like the approach. There's so many issues that they're just diving right into this, and they're not talking about how they're going to address any of the issues. So so like there's the data bias feedback loop. So predictive tools they amplify historical policing biases, right? So if Black neighborhoods are over policed, their crime data becomes overrepresented, which leads algorithms to recommend more patrols there. So it's kind of a self-fulfilling prophecy of discrimination, which is this is just scary.
And then anybody at any time could put their thumb on the scales, I would imagine. And this is another thing when you don't have the checks and balances. And, these predictive algorithms are bound by the quality of their data, and flawed historical records could compromise the reliability of predictions, perpetual existing biases in policing, as you mentioned. But the UK's implementation of murder prediction algorithm marks a transformative phase in crime prevention strategy. This proactive method seeks to identify individuals deemed high risk for violent behavior. However, challenges arise, including risk of misidentification of individuals and ethical ramifications of such technology. And critics highlight the lack of transparency regarding how data is used and the mechanics governing its application. So you feel like a person of interest, the phone rings and gives you a SIN number, and you don't know whether they're going to be the victim or the criminal.
And so I really did a deep dive into this. Okay. So I found some research in this. So Amnesty International did a report in 2025. They found that 33 UK police forces use predictive tools that disproportionately target racialized and low-income communities. Over policing generates dirty data that created biased feedback loops. MIT did a study on the victim data because, let's include victim data. That should help. No, even when using victim reports instead of arrest data, predictive tools still skewed toward minority neighborhoods due to reporting disparities. Wealthier white individuals report Black suspects more often, which distort risk assessments. And finally, I'm going to skip one that I did just because I'm going to go to this one. There was U.S. predictive policing failure. So programs in L.A. and Chicago were scrapped after ineffectiveness and racial bias. New York's Strategic Prevention Unit reduced murders by 5%, but it faced criticism for targeting Black and Latino youth. So, there's red flags across the board with this. I think they're going in the wrong direction with this, and they're not doing it cautiously, carefully. I think they're trying to rush to get something in, and it's going to backfire. Sorry, I'm passionate about this.
No, I agree with you. I think I sit back and say, well, what does backfire mean? It just seems like the government doesn't care.
Oh, thank you for raising that. So again, with everything going on, it seems like there's no more accountability for anything that's happening. So, you're right. I think this is just going to keep moving forward, despite all of the errors, despite all of the protests, despite all of the problems, because there's no longer accountability with anything anymore. So,
and it's scary, again, every time there's a black box on what's happening, and then we just agree with the outcome. Buy stocks, you're going to be a murderer, we're predicting an outbreak of disease over here, whatever. Who's putting the thumb on the scale behind it? Who's writing the AI prompt to get the output? So when you start sitting back on this stuff, you gotta wonder that, is this just another tool that can be abused? Now, I mean, in an ideal world, we want to have personal accountability. We want criminals to, face the repercussions of their actions, whatever they may be, at the appropriate level. You do a minor thing, minor stuff happens to you, whatever that might be. But we live in Canada. It might be different in the States. It might be different. It obviously is different in the UK. But I want better tools for the police.
Yes.
But I don't want overreach. I don't want your rights to be violated. I don't want people over patrolling a neighborhood because a computer told them to. So how do we prevent that?
We need the balance. And how do we get that balance? And there is nothing that I know of currently that we could use, that we could implement. There's no potential solutions that we could use to mitigate this. Something new needs to come along.
So this is just a reminder that the majority report is real. It's not fiction, and the offender assessment system is live in the UK.
Minority Report.
What did I call it?
Majority Report.
Majority Report. Well, maybe we're all criminals now. I don't know. The Minority Report is real, and the offender assessment system is live in the UK. This UK murder prediction algorithm embodies both innovation and inherent risks associated with predictive policing. As these technologies advance, deliberation on ethical and use of civil liberties remains imperative. So what do you think of this? Is there a future in pre-crime, or does it scare the crap out of you? Who was it that said, show me the man and I'll show you the crime?
And
that, again, has to do with being able to look backwards and find stuff. Like when all of a sudden one day support the truckers, give them is out of Justin Trudeau's mouth. A week later, it's the truckers are terrorists, we have to shut down their bank accounts. And if you followed my advice 2 weeks earlier and gave them money, you're now a terrorist. I'm like, what happened?
Yeah.
So that kind of stuff is very scary. And that kind of comment was towards that. So let us know what you think. We'd love to hear your feedback. So Meta, Facebook's parent company, is facing an antitrust lawsuit related to WhatsApp and Instagram. What's going on here, John?
Yeah. So is this, before we dive into it, is this because of the whistleblower? You know?
I don't know if it is because of the whistleblower, but I think the whistleblower added a bunch more information to it.
Yeah.
I think, the acquisition is under scrutiny because they bought Instagram in 2012 for $1 billion and WhatsApp in 2014 for $19 billion. And they're like, are you cornering the market? Is this a thing going on? Go ahead.
So they said that they were buying WhatsApp and Instagram for business expansion. But the government's case is built on internal communications that include emails from CEO Mark Zuckerberg, which suggests that they're doing a buy or bury approach to the competition. So they're saying that they did strategic moves to neutralize emerging competitors and cement Facebook's dominance in the social networking market. And apparently this trial is super technical, and it's focusing on market definition and competitive effects. So they're arguing that Meta's control over platforms for sharing content with friends and family constitutes a monopoly. Yeah, maybe. And that the acquisition stifled innovation, reduced consumer choice, and led to lower privacy standards. So interesting. I could go into a lot more details, but I'd love to get your thoughts on this, Craig.
Well, the FTC argues for a narrow definition around personal social networking, suggesting that Meta holds a monopolistic power in this specific segment. This definition is crucial to all this because it excludes TikTok, YouTube, and X as direct competitors. It focuses on friend and family connections rather than content discovery. It suggests that Meta's faces limited domestic competition beyond Snapchat and MeWe, and it frames Meta's acquisition as an attempt to dominate this specific niche of social networking. So
Yeah.
I have two schools of thought. In the startup world, at Y Combinator, all the investors, they always say, is this a buy or bury? Is this a build or buy? Type of thing, and it's out there, and it's promoted by investors, it's promoted by mentors, it's promoted. So when somebody actually does it, this is a problem.
Well, maybe it's the way they did it. I don't know.
like, so I agree.
Yeah.
I just have to take a step back, and every time, we see this type of stuff, we have to say, okay, with the Google Chrome, with whatever, like, are these truly anti-competitory, or is it something else? So I'm always curious when we see these things, as more social networks emerge, and we're OpenAI seems like they're building their own in the background. There's many stories around that happening now. So the question is, why is it your relationship connections? It's the network that they're tracking. That's the problem. Who's in your group on WhatsApp that you're chatting with, and who's in your group on Facebook that you're talking to, and who are you connected to, and all that stuff. So I guess it's that social graph piece on Facebook that's the problem.
Yeah. So this is interesting because they might set a new regulatory precedent if they win, because the case is testing whether U.S. antitrust law can retroactively challenge mergers that were previously approved based on their long-term competitive effects. So this, if they do win, which this is going to be a tough one because of the precedent that it's going to set, but if they do win, then no mergers is ever safe, I guess.
Yeah, it's just, the company's email suggests that Meta prioritized buying potential competitors rather than competing through innovation.
Yeah.
Build or buy. Those are decisions that are made all the time. And now if there's an email or some recording that says, should we build this or just buy somebody who does this well and add it to our portfolio, and all of a sudden that becomes anti-competitive, or is it actually anti-competitive? Like, this is why these things are a little vague when we read through them, and it makes me skeptical, because is this wild government overreach, or are this big corporation screwing us? I want to know which one it is.
Yeah. Well, I do know that Meta's data privacy policies are absolutely horrific. They're one of the worst I've ever read. So I see that, but yeah. So there is, I don't know. There is competition though, because there's, like you said, there's TikTok, there's YouTube, there's and YouTube's very popular. So I don't know. I don't know how, but here's the thing that I like it, if there is internal communication that comes out as to the actual reason for buying it, and that shows that it's more to monopolize than to just expand, then yes, go after them 100%, because then you lied, right? Then you lied about your intent.
I guess. I mean, it depends. I guess, as far as I'm concerned, I don't know. Like, did they have to file a whole bunch of stuff with the government and then lie about what they were doing? And if that's the case, then yeah, definitely. If they're just telling somebody, saying, hey, we're doing it because of these things.
Yeah.
And, those are only 3 minor things. There's actually 3 major things. And because people do things for all sorts of reasons. So, with X trying to create the everything app, and them going after WhatsApp and trying to buy the market, it seemed like a natural thing. However, natural could be anti-competitive when we're saying, Facebook and Meta, you're big enough already. Stop taking more chunk of the pie away from everyone else. It feels like a socialistic move rather than a capitalistic move.
Yeah.
So I just curious as to, from the stuff I've seen here, is it the hidden information that they're dealing with that no one else has that's the problem, and that all our internal relationships? And so what are they saying the answer is? That they want to open up our internal relationships to everyone else, or Facebook's got to stop tracking it?
Yeah, I don't I don't think so. I think it's like, from what I read, I think it's more of the intent of the purchases. That's what I'm getting from it, but I could be wrong though.
So the case probes fundamental questions about what constitutes healthy competitive competition in social media markets, and how dynamically evolving platforms should be evaluated under antitrust frameworks. Meta's defense emphasizes that rapidly changing nature of digital competition, where new entrants like TikTok can quickly capture massive user engagement, where user preferences continually evolve. This perspective suggests that temporary market leadership should not be confused with durable monopolistic power. So the court's determination will influence how companies approach acquisitions of emerging competitors, whether platforms emphasize differentiation or integration, investment patterns in social media startups, and the evolution of content discovery versus social connection features. So we'll have to see what they do.
Yeah, this is, well, we'll definitely track this one. This one's interesting. So I like that. I have to say, I do like that the FTC, and I said this before, is growing some cojones and challenging some things now, right? Whereas before it was just status quo. People could do whatever they want. But who knows where this goes?
Regardless of the outcome, this case represents a pivotal moment in the evolution of a digital platform regulation. Several potential scenarios could unfold. Complete divestiture of both Instagram and WhatsApp, creating new independent competitors in the social media landscape. Partial remedies that maintain ownership but require operational separation and reduce sharing between platforms. Behavioral remedies that impose ongoing restrictions on Meta's business practices without structural changes. And a ruling favoring Meta that maintains the status quo but potentially includes some operational constraints could, trigger different things. So we'd love to hear what you think is going to happen with this court case. And with Meta's market capitalization approaching $3.3 trillion, the stakes extend far beyond the company itself. So I'd love to hear what your thoughts are on the future of WhatsApp, Instagram, and Meta. Magneto-resistive random access memory. Is this the future of next generation RAM, John?
I don't know, and this one was kind of difficult for me to wrap my head around. But let's dive into it. So they've developed what's called a multiferroic heterostructure, which is MRAM. Sorry. What that does is it significantly reduces energy consumption during data writing. So the design that they did is it encapsulates a vanadium buffer layer between ferromagnetic and piezoelectric materials. And what that does is it enables electric field controlled magnetization switching instead of the traditional current driven methods, which apparently cuts energy use by orders of magnitude. So the key innovation here is that vanadium layer that stabilizes magnetization direction fluctuations, and that allows reliable switching at 1 volt with minimal heat, which addresses MRAM's historical trade-off between stability and energy efficiency. So this is interesting. It's interesting. What are your thoughts on this?
Well, the concept is great. It's kind of like e-ink, for lack of a better thing, for your RAM. It's turned on or turned off, and then it's just left.
Yeah. So like the vanadium layer, it's don't think of it like a buffer. It's more like a stabilizer. So what it does is it helps to dampen thermal noise that previously caused erratic magnetization, which enables reliable low voltage switching. So think of it like a shock absorber for this. So this is really cool.
And apparently it's way faster.
Yeah, apparently it is. So I know that I think NVIDIA and TSMC are exploring MRAM. And then there's other advancements with IMEX, SOT MRAM. So there's a bunch of different innovations here going on, competing technologies, which shows that this is worthwhile, or this is a viable next step, right?
Yeah, and the concept of integrating, this as non-volatile storage, it's faster, it's enhanced durability, just because of the way it works.
Yeah,
And yeah, it seems great. The startup performance provides immediate data access on power up because, the DRAM doesn't need, it's already ready.
yeah, yeah. So yeah, go
We'll
ahead.
have we'll have to see as how quickly modern commercial computer systems start adapting this. But if it would extend their system lifetime, reduce, like you said, thermal disposition, faster boot up times, and enhance reliabilities. Imagine these types of things in your tablet devices, right? Where you reboot, but the memory just stays, so it comes back to exactly where you were.
Yeah, exactly. And just to put it into perspective, this is essentially what they're saying. It's 1,000 times more efficient than conventional RAM. So that's crazy.
Yeah, just imagine what we could do with edge computing applications at 1,000 times the speed, AI accelerations, faster model training, reduce energy costs, improve inferencing. They're talking about building those multi-billion-dollar AI data centers and
Yeah,
using nuclear power to power them. We really need to take as much of this energy efficiency as possible. Low power devices that'll extend battery life, smaller device footprint, instant wake functionality, and data persistence across reboots and stuff. So
yeah.
the advances are significant. What are some of the challenges to getting it in my hand?
Well, there's definitely some scalability challenges. There's production. There's I think I don't know if they've tested the durability of it. I couldn't find anything, but what did you find as far as challenges?
Long-term performance concerns, time-based degradation. Studies have not comprehensively tested that MRAM cells might degrade over extended period of time. Environmental factors, the impact of temperature variations, electromagnetic interference, and other environmental conditions require further investigation. Scaling questions remain about how performance characteristics might change as manufacturing scales to meet commercial demand. Write cycle limitations, error rates over time, recovery mechanisms, and manufacturing and integration challenges, production complexity. The multi-ferroic heterostructure design involves sophisticated manufacturing process that must be optimized for cost-effective mass production. So it's going to take a while.
Yeah,
And then compatibility and integration with existing systems with current computing architectures require careful integration, design, and standardization. And all this has to go through that process to get yield rates to a level where you're producing a consistent product that actually works, right? You would talk about
exactly.
chip
Yeah,
rates failing and all that kind of stuff. So,
yeah,
and then market adoption, established infrastructure, cost consideration, and industry standard. So the market moves when the market moves. So they'll have to get the yield rates down to a good level, and then somebody big is going to have to make the move first.
yeah. And as long as they make it somewhat compatible with, or make it easy for for electronics manufacturers to integrate it, then yeah, it's a no-brainer kind of thing. But we'll have to see.
So let us know what you think. Are you ready for this? Or do you think this is another pipe dream where this is a technology we're not going to see for a long, long time? I'd love to see this in my hand soon because it looks like it's a great technology, faster, more efficient. We should be looking
Yeah,
at this a lot if it actually works.
yeah,
All right. Well, we'll cover this anyway. We got a little bit of time, not a huge amount.
no, we'll cover this quickly.
All right, scientists haven't
Hmm.
brought back dire wolves from extinction in a Jurassic Park style, but not really. Tell us what's going on here, John.
Yeah, I guess we didn't learn from the Jurassic Park movie. So they've claimed to de-extinct the dire wolf, which is a species that went extinct about over 10,000 years ago. So they've used advanced genetic engineering techniques and edited 20 genes in gray wolves to mimic traits of dire wolves, such as larger size, broader skulls, stronger jaws, and unique vocalizations. So the process that they did was they isolated endothelial progenitor cells, EPCs, from gray wolves' blood, edited their genomes to match the dire wolf DNA, and then implanted those embryos into surrogate dogs, which led to the birth of 3 pups: Romulus, Remus, and I can't pronounce the third one, Khaleesi.
Probably, yeah.
Yeah. But critics are saying these aren't dire wolves. These are just genetically modified gray wolves because they targeted 20 genes out of approximately 19,000 in gray wolves. So, what do you think about that?
Yeah, I guess it's important to note that they didn't find something in amber and then get extracted blood, and apparently doing that is next to impossible based on the articles we read around that. So they're just genetic engineering what they want, and that is a little bit scary. Scientists rely on remarkable ancient DNA sources to guide these modifications, and the primary samples include 13,000-year-old tooth and a 72,000-year-old ear bone.
Crazy.
Yeah, to figure out this thing. The genetic process for the direwolf resurrection, if you want to call it that, involves 20 key gene edits of, what do you say there were? Thousands?
19,000.
There you go. So it's scary because we're just creating what we want. I feel like this is the other direction from the Boston Dynamics robots and stuff we're seeing. We're saying, okay, you can create stuff like that, but you can also create stuff like this.
Yeah.
And I feel like, we're going to have Transformers versus the Manimals pretty soon.
Yeah, wasn't there Beastie Transformers or whatever?
Yeah.
We'll have those. Speaking of which, we need to cover. There's this Kawasaki horse that you can buy. That's hydrogen power. We'll cover it in another one. It's something you can actually buy, but we'll cover it next time.
So Colossal Bioscience has rapidly established itself as a powerhouse in genetic conservation technology with a team of 130 dedicated scientists specializing in genetic engineering and conservation biology. The company ambition extends well beyond direwolf de-extinction. So scientists were very critical of this, saying, understand that this is not de-extinction, even though that's what they're calling it.
Yeah.
That once a species goes extinct, there's no bringing it back. So don't think that we can just kill whatever we want and bring it back. And that's not a mindset humanity should have. So they wanted to be clear about that. So their comprehensive approach to genetic conservation includes several interconnected projects. They want to do ghost wolves, red wolf clothing. They want to do woolly mammoth, which I hear is next, genetic engineering, and then thylacine restoration, efforts to restore the Tasmanian tiger, focus on reconstruction of the extinct marsupial's genome and implanting engineered embryos and related species. While interesting, I always go back to my question of why. Why are we doing this?
Yeah, the thing that you have to think about too, right, is if you do bring back these dire wolves or any species, right, you got to think about that. You're bringing them back into an environment where the ecosystem has changed. So they were specialized hunters, and they adapted to prey that no longer exists today. So how would they fit into our modern ecosystem?
Yeah, and the article here talks about rewilding. We won't get into it, but that's exactly it. What happens when you introduce something like this back in the wild? It upsets the natural predator-prey dynamics. And things just go out of wacky. Like, why are we going to keep these in the zoo? Are we creating a Jurassic Park for these types of animals for everyone to go see it? Or is this going to be ultra rich get to create whatever they want? Like, why are we doing this?
Exactly. Yeah. Why?
I love the CRISPR technology and the fact that this is showing us what we can do and some of the fantastic things. These things are bigger, they're broader, they're wider, their hair is shaggier based on all these things. Is this just a demo to say we can give you the ultimate child with all the earmarks of what you want?
Yeah.
So, independent ethical review boards should evaluate genetic interventions in conservation. Understanding the balance between technological innovation and ecological caution remains essential. Like we talked about, what can you imagine throwing woolly mammoths back into the environment, or even these wolves? How long till they are, the dominant species of wolf in North America if you just throw them out there?
For sure. Yeah, it's scary. It's scary to think that.
Yeah, as apex predators, reintroducing dire wolves would likely influence ecosystems through several mechanisms: regular prey populations, modifying prey behavior, competition with existing predators like wolves, cougars, and bears, carry-on provisions for scavenging community, and potential trophic cascades affecting vegetation structure and more. So this is scary and cool. I mean, if you watch the videos with the little puppies crying and howling and stuff, it was like, oh, isn't that cute? But those things will grow up to rip your face off if you let them. So are we as a society ready to start genetically engineering whatever we want, or bringing back so-called extinct species because we want to recreate, know what they look like, understand them better, whatever it is? I'm really concerned. I'd love to know what your thoughts are. You concerned, or is this just a fun ride and you can't wait to have your own baby direwolf?
Yeah, exactly.
Leave your comments below. So this is going out, like I said, early May, mid-May, and we've got the startup investor drinks. I'm going to say consensus after party. Sorry, I was going to say collision. It's consensus this year after party.
Yeah.
And we have a Flowgrammer event talking about automation and AI and cryptocurrency. And the week before, there's a big hackathon that we're proud supporter of as well. So
Nice.
check out Toronto Starts for all that stuff. What do you got going on, John?
Yeah, Consensus Futurist Conference, which will be fun. There's a Web3 conference the Monday. Lots going on that week for Crypto Week, so come check it out. There's plenty of tickets left, I think, for all three, so come on, check it out.
And check everything else out at torontostarts.com, and we'll all talk to you soon. Thanks for watching.
Thanks, guys.